I decided I'm going to teach you guys how to do determinants now because I see that is going to be very helpful when you do your homework. Okay, so we're going to take a little side note today to just talk about something called determinants. So first of all, let me tell you that a matrix is just a rectangular array. Like, for instance, this. Some people put brackets around them. Some people put parentheses around them. Okay, that's what a matrix is. This is called a 2 by 2 matrix because there's 2 rows and 2 columns. You always say the number of rows first and the number of columns second. Okay, now the determinant of a matrix okay, you write the matrix. Now this is for a 2 by 2 matrix. You write the rectangular array, and then instead of putting brackets or parentheses around it, you just put vertical lines around it. That means determinant. Okay, and here's how you calculate the determinant. For a 2 by 2 matrix, what you do is you multiply, let's do this in green, okay? You multiply these two, A times D, and then subtract and then you multiply those two, B times C. That's called the determinant of a 2 by 2 matrix. Okay, now let me show you how to do the determinant of a 3 by 3 matrix. So I'm going to write ABC, DEF, GHI. That I is not the square root of -1, it's just a variable I. Okay? So the determinant of that, I'm going to show you a couple of ways of doing it. Okay? So one way is to do this. You take A times the determinant of this 2 by 2 corner. So that would be A times the determinant of the matrix with EF, HI. Okay? And then minus, the minus is very important. And then you take B times the 2 by 2 determinant with these 4 numbers. So that would be B times the determinant of the matrix with DF, GI. Okay? And then plus, very important to switch back to plus, okay, this number times the determinant of this 4 by 4 corner. So that would be C times the determinant of DE, GH. Okay, so if you work that out, here's what it comes out to be. A times EI minus FJ. Oh, sorry, I said FJ, I meant FH. Okay. Minus B times DI minus FG. Plus C times DH minus EG. That's how you do the determinant of a 3 by 3 matrix. Okay, now I'll show you another way of writing that. I wouldn't call it really a shortcut. It's just another way of doing it that a lot of people find easier to remember. Which is to do this. You go ahead and write the 3 by 3 array and then copy the first two columns over again. And then what you do is you multiply these three, multiply these three, multiply these three, and add those up. So you would get AEI plus BFG plus CDH. Okay, and then you multiply these three, multiply these three, multiply these three, and subtract those. So we would have minus CEG minus AFH minus BDI. Okay, and you can compare and you can see that this gives us the same thing that this does. So either of those two ways, that's how you calculate a 3 by 3 matrix. The determinant of a 3 by 3 matrix is what I meant to say. Okay, so why are we discussing this now? Because this gives us a very easy way to remember how to do cross products, and it also gives us an easy way to calculate a scalar triple product. Okay, so let me show you how you can write a cross product as a determinant. Suppose that you would like to calculate, let's say V is the matrix 2, 5, 1, let's say, and let's say U, I said matrix a second ago, I'm going to say vector, sorry. U is the vector, let's say 3, 4, 7. And you would like to calculate the cross product of V and U. Okay? So, one way of doing this is as a determinant, where you put V in the second row and U in the third row. So I'll put 2, 5, 1 in the second row, 3, 4, 7 in the third row. And then in the top row, instead of writing numbers, you write the 3 standard unit vectors. Do you remember those? I, J, and K. Like this, their names. You write their names. I, J, K. All right, let's calculate that determinant. So that would be, let me get a different color here. So that would be the vector I times the determinant of this corner. So I'm going to write that like this. The determinant of 5, 1, 4, 7 times vector I. Okay, and then minus, whoops. Okay, then minus the vector j times the determinant of 2, 1, 3, 7. So I'm going to write that like this. Okay, and then plus vector k times the determinant of 2, 5, 3, 4. Okay, so what's that going to give us? That's going to give us 5, 7 minus 1, 4 times, oops, so 5 times 7 minus 1 times 4 times the vector I minus 2 times 7 minus 1 times 3. That should have been a 7 there. Times the vector j plus 2 times 4 minus 5 times 3 times k. Okay, so what's that give us here? Let's see, 35 minus 4, so that'll be 31 times the vector I minus 14 minus 3, that's 11, times the vector j plus 8 minus 15 will be negative 7 times the vector k. So we get the vector 31, negative 11, negative 7. Okay? Now, if you take the formula that I gave you in the previous lecture, the formula for cross product, you will see that this comes out to be the same. Okay? So what's the benefit of writing cross product this way? One of the problems is that I look at the screen right now and it looks like I did an awful lot of writing to get the answer. So why do I bother with writing it like this? Well, a couple things. Number one, if you forget the formula for cross product, the formula that was in the lecture yesterday, it's very easy to forget that. If you forget that, then what are you going to do? Well, the point is, it's a bit easier to remember this pattern. Or let me not even circle that. Let me just circle this. It's easier to remember that. If you remember that and you know how to calculate a determinant, then you don't need to memorize the formula for cross product. All you have to do is remember that cross product is that determinant. And if you know how to calculate a determinant, then you'll be able to do the cross product. Okay? Another reason why is because if you struggle on some homework problems, you can read their explanations online, and in their explanations they're going to have things like this written as a way of explaining how to get the answer. And I want you to be able to understand what you're seeing. Okay? Now, one other thing. So that's how determinants can help us remember how to calculate a cross product. Okay? Now, one other thing determinants can help us with. Determinants make a scalar triple product really easy to calculate. Let's even do this here. Let's just use the same u and v. Let's just add a third vector on there. I would like also, because we're doing a scalar triple product, I'm going to switch the order here. Let's put UV instead of VU. Okay, and let's put a third one on here, W. And let's just say that W equals the vector with these components, 6, 8, 9. Now, suppose you want to find the scalar triple product. U dot, so that's the dot product of the vector U with the vector V cross W. Do you remember what that would tell us? That tells us the volume of the parallelepiped spanned by those three vectors. Okay, so we did one like this in the lecture yesterday. And what we did was we calculated V cross U and we got an answer. And then we did the dot product of that with U. Alright, well, actually there's a very quick way of writing this down if you know how to do determinants. The answer to that will simply be the determinant of the matrix with U in the top row, W in the next row, and I mean V, sorry, in the second row, and W in the third row. That determinant will tell you the area of the parallelepiped. Okay? So how would we calculate that? That would be 3 times the determinant of 5, 1, 8, 9 minus 4 times the determinant of 2, 1, 6, 9 plus 7 times the determinant of 2, 5, 6, 8. That would be the scalar triple product. Let's finish calculating it. That's going to be 3 times, there's 45, minus 8 would be what? 37, right? And then minus 4 times 18 minus 6, which would be 12. Plus 7 times 16 minus 30, which is negative 14. And let me just quickly calculate that here. So that's 111 minus 48 minus 98. We get negative 35. That's the scalar triple product, is negative 35. Now, if you wanted to know the volume of the parallelepiped, I should add that that is equal to the absolute value of the scalar triple product. So the volume of the parallelepiped formed by those three vectors would be a volume of 35 cubic units. Okay, so this is a topic that comes from linear algebra. This thing of determinants comes from linear algebra, and it makes it very easy for us calculating things that deal with cross products. And we'll probably see it again in certain kinds of integrals later in the semester. All right, have a good day.